In this video, we're going to talk about formulae, and we're going to talk about the idea of making something the subject of a formula. But before we do that, I want to make 4 important points. The first one is that an expression is something that contains letters and or numbers, but no equal sign. For example, x plus y, 2x squared minus 7, 43. There's no equal sign, there's just some letters or some numbers. An equation does have an equal sign and some letters and numbers, and what you do is you solve equations to find the value of the letter. So for example, x minus 4 equals 5, you'd solve this equation and it only has one solution, and that is that x equals 9. So number 3, an identity is true for all values of the letters. So 6x divided by 3 is always equal to 2x. No matter what you put in as x, this is always true. So that's why it's an identity. It's the exact same thing. And now on to point 4, which is what this video is about. So a formula has an equal sign and letters to represent different quantities. So for example, a equals pi r squared, the area of a circle, or e equals mc squared. So the letters here are called variables because their values can vary. So we may be told different values that these could be and use them to work out what we're asked for. So let's do a quick example. If we're using the formula d equals 2e squared plus 8f over the square root of g to calculate d when e equals 2, f equals 3, and g equals 4, all you have to do is put the respective numbers in the places they appear in the equation. So all you do is you write d equals 2 multiplied by, well, e in this case is 2. So we multiply 2 by 2 squared plus 8 lots of f. Well, f is 3 in this case. 8 times 3. And we divide that by the square root of g. And g is 4. So we divide that by the square root of 4. And that is equal to 2 times 4, because 2 squared is 4, plus 8 lots of 3 is 24, divided by 2. And this is just equal to 8, because 2 times 4 is 8, plus 12, which is 20. So when e, f, and g take on these values, d is equal to 20. And that's just simply plugging numbers into a formula to get your answer. So let's do a bit of a more tricky example. So we're asked to write a formula for the area of a triangle in terms of b, the base, h, the height, and a, the area. And then we're asked to use this formula to calculate certain values. You should all know that the area of a triangle is simply equal to, so we can write area is equal to 1/2 times base times height. And here, the base we can label b, the height we can label h, and the area we can label a. So our formula can be a is equal to 1/2 times b times h. So now we've got to use this formula to calculate, first of all, a when b is 7 and h is 2. So all you do is you say, well, we're working out a, so a is the unknown, so we put a is equal to b times h, 7 times 2, divided by 2, which is 14 over 2, which is 7. So a equals 7 in our first case. In our second case, so part 2, we're now asked to calculate b when a is 26 and h is equal to 3. So we got the exact same formula here, a equals b times h over 2. So but this time we're given a, so we can write 26, which is a, is equal to b, which is the unknown, times h, which is 3, divided by 2. And this is where we just need to rearrange this equation so that we solve for b. So just as we did in the last video, what you do to one side you must do to the other. So if we times both sides of the equation by 2, we get that 52, which is 26 times 2, is equal to b times 3, or more simply, 52 equals 3b. And now, if we divide both sides of the equation by 3, we get that 52 divided by 3 is equal to b. And there's our answer. b is equal to 52 divided by 3, which I think is 17.3 recurring. So the subject of the formula is the letter on its own on one side of the equal sign. So for example, In the case x equals 2 pi r, x is the subject of this formula because it's on its own on one side of the equal sign. In the next example, we're just asked to make x the subject of the following formulae. So we're doing the exact same thing as what we did when we were solving equations, but it's all letters now. So it should be the exact same process. So y equals mx plus c. Well, we can minus c from both sides of the equation. So we get that y minus c is equal to m times x. And now if we divide the whole thing by m, we'll get y minus c divided by m is equal to x. And that's our answer. X is equal to y minus c over m. So s is equal to ut plus a half xt squared. So again, we're making x the subject, so we want x on its own on one side equaling something. Well, first off, let's get rid of the other term on the side of x. So if we minus ut from both sides, we'll get s minus ut is equal to 1/2 xt squared. Now, if we can get rid of the half by timesing both sides of the equation by 2. So we get 2 s minus ut is equal to xt squared. And now if we divide everything by t squared, we'll get x on its own. So dividing both sides by t squared gives 2 s minus ut over t squared is equal to x. And that is our answer. X equals 2 s minus ut over t squared. So now we're asked in part 3 to make x the subject of this formula. Well, we always want to get rid of divisions when we can, so if we multiply through by v, we get that tv is equal to 3 minus x. Now if we add x to both sides, we get that x plus tv is equal to 3. And if we minus tv from both sides, we get that x is equal to 3 minus tv. And there's our answer. But yeah, and that concludes this video on formulae and making things the subject of formulae. Thanks for watching.